So we're going to talk about active learning for both humans and machines. And I'll talk about the Tangible AI internship and some opportunities to do some active learning with us. Then I'll talk about what active learning is for humans and machines, and then I'll try a demo of doing it for real with machines and humans simultaneously. So the internship starts September 8th. It's 10 weeks. If you can give 10+ hours a week, then you'll get a lot out of it. It's educational. You can work on Python and machine learning, or even web development or conversational design, depending on what your interests are. And you get, it's a self-directed project. We have some project presentations coming up Friday, September 10th for the summer session, so you can join us there. It's on the same Zoom channel at 9 a.m. Friday, September 10th. Send me an email if you want more information about the internship or any of those events. Hobson at tangibleai.com or engineering@tangibleai.com. Human active learning, what's that? Well, it turns out it's exactly what Guido van Rossum and a lot of the core developers at Python decided was really important for the Python interpreter really early on. So they created a REPL for us. And it normally means read, evaluate, print, loop. That's what the acronym stands for. But I like to think of it as read, execute, then print, and learn. So as you're going back to that, to redo the reading of your code, you should do some learning along the way. And so that involves actually examining that print statement to see what's in those variables and actually trying to understand whether your mental model, your predictions of what that code was going to do actually came to fruition. And if not, learn from that difference and continue to do some more prints or more displays of what's going on. That print, that you don't actually have to do that in IPython. If you just execute your lines one at a time, and you just if anything that you put on the command line will be printed to the screen automatically in a nice pre-print sort of format. So I'll show you about how that works in a moment. Also, that diagram was created with Digraph Viz. So in case I don't get through the demo successfully, this will give you a little bit of Python to scratch your itch. So we've got a YAML file reader that actually converts stuff like this into diagrams like you see below. So all I had to do was put this REEPPL to create those edges. Didn't even need to do this. That's part of the actual defaults for the diagram. Anyway, and some Python code that actually does that. So you just read through that list of edges from the YAML file, and you just add them to Graph Viz in order to create it. You can give it some other options, obviously, make prettier diagrams. It's really awesome if you want to turn your diagrams and your presentations into code instead of having to redraw everything you do every single time. Let's see, screen sharing is not on.
I can definitely see your screen.
Okay. No worries. Brian Tucker was asking for a screen share. Anyway, we've got, and this is just so you know what Graph Viz does, you create a big class called Digraph, and then you just add all these nodes to it. So the previous code you saw was just building off a Graph Viz object. Okay, enough of Python and diagrams and human active learning. So when it comes to machines, they've learned recently that this is actually a really good approach to teaching machines, and it can teach machines in a similar way to humans, where you don't have to give them a ton of data. So what you do is you give them some labeled examples. This is like creating quizzes or sets of paired up things of like, this is what I want you to predict, and this is what the question's going to look like, and this is what the answer looks like. So you give it just a few examples, and then you split that into some training and some testing examples. And so this would be like pulling out some of those and making them an exam. So then you train a model to answer the quiz questions, and then once the machine gets really good at that, you give them an exam and you grade them on that exam. And then you give the model back some more training examples based on the ones that it missed in the exam. So just like a human, when you get something wrong, you try to practice it again. And just like we're doing in the REPL in Python. And so you give the machine a set of just those few examples that it got wrong or got very close to getting wrong. So in many cases, you can actually see the probability or the confidence that it has in each of the predictions it's making. And so you give the model answers for the missed ones, and then you create harder test examples and keep building up your data set incrementally. This makes it focus on just those edge examples, and so it builds up sort of this space of all the. And I'll give you some concrete examples in a moment when we go to the REPL and start working on an actual problem. So it's going to be, think of it as like fake news. So we're going to give it a bunch of fake news titles, and we're going to give it a bunch of real news titles, or authentic news titles, I should say. So this comes from a data set on Kaggle for doing this. Then we're going to, so I'm just going to go to a few of those, and then we're going to train a model. And so it's going to learn to recognize words that are associated with fake news. And then we'll try to, we can maybe even add some titles ourselves to try to give it some hard examples that are kind of fakey, but not super fakey. And we'll see how it goes. I guess I should go ahead and get started because this is going to be really difficult. So we're on the REPL because that's where active learning happens. And so we're going to try to display the thing that most people forget to do when they're doing this. So like what I've done is I've gone ahead and load the raw data sets. This is a massive data set. So this data set was designed for the conventional approach where you have tons of data. So it's got a decent number of examples. Turns out, but after you do something like this, like you've read in your data, first thing you want to do is examine everything you did there to make sure your mental model is correct. So I know mine's correct, but I'm going to check it anyway. So I'm going to see what's in that data frame object that's DF. So I assumed that this read CSV was going to read that file correctly, and sure enough, it did. But I learned some stuff. I learned what's in that actual file. I may not have had a good mental model of what was in that file, what the columns were. Also, there's something, a little trick in options display. We want to increase the number of columns that we can display, so we can get into the we don't know what else is in this data set that we're looking at. See, we don't even see a label yet here. So options.display.max columns. You can do tab completion often to find things you're looking for within a package in Python. So don't forget that. It's another good active learning tool in your toolbox. So you can just try things and figure it out. So I'm going to try something on and just change this max columns. I'm going to change it to 1,000, and then you can then display just do the active learning thing. I'm going to display and make sure that it actually held that variable there. See if there's any other information about what this thing is. This is if you really want to dive deep, you can go really deep in active learning about learning all this stuff. Let's move on. So let's just display that data frame again. So now we got all the columns, and it's going to wrap around a couple times. So we got the title, we got the text, we got the subject, we've got the date, we got it is fake. That's the actual label. And you notice that I discovered something real quick here that's kind of scary. Is I've got is fake before all the fake. So if we just train this in order, we might end up training the model to cheat. Basically, it would measure the first half as all being fake and not fake, and the second half is all being fake. So it might learn something from some unintentional features we've added today. So we're going to do is a sample real quick. I'm going to do df small to create the small sort of set of examples that you've gone in and created a bunch of hand labeled examples. So let's see how well it's going to work. df.sample, let's just give it 100 examples. That's typical for what somebody's willing to do in a reasonable amount of time. And we'll make df test will be, let's look at it. Oh, I got to do my active learning. Let's make sure that did what I wanted to do. So I just assumed that df.sample is going to give me a random sample. Okay, it looks pretty good, but that sample doesn't look super random in terms of is fake. There's only one fake in the first 5 and last 5. I wonder if it came out fully random. Let's check this out. Let's see, but it does look like it did sort of randomly choose rows, so that looks pretty good in terms of random row numbers. Let's take df small dot. Let's take another sample, just a sample of a sample. Let's take 10 of those. Okay, there we go. So that looks like that's starting to get more like 50%. Another sample. Okay, if I keep sampling, it looks like it is. We just got really unlucky with that first sample that we showed up on the screen. So we're good to go. So now let's import. Actually, yeah, let's go ahead and import. Let's say from scalar.linear model. Let's do this. We don't need all this. Great. Also need to import a thing called a TF-IDF vectorizer. It's in the, so I'm going back to my, let's see what these things are just to practice. It's not going to tell us much. So you want to examine a little deeper by using the question mark after in IPython. You can look at the actual documentation. So this is what I'm looking for. It's a class that allows me to give it text and split it and create a vector out of it. And let's do the same for something like, well, I'll just do linear regression real quick. It's a real simple interface. Actually, it's not. Let's move on. Normally, check that out. So let's create a vectorizer. Here we go. We're going to do it only on the title, so we're not going to look at the text of the article and see if that's enough to predict fake news. Also, I need to create that. Did I create a DF test set or not? I've got DF small dot shape. Let's see. So we got 100 examples. Let's just grab 30% or 20% of that guy. DF small high low. I think that'll work. See if I can do something like this. Negative 30. Well, I never want. Let's just grab 20 examples from the end of it. Actually, we can do a sample. Oh, but then we'd end up with those we left in the training set. So I can take the last 30 of this thing. It looks like a decent sample. Looks like it is about 20 examples. Okay, great. So let's make that df test equals df small. And we'll take df small. We're going to do some not good coding here. Just put it all on one line. Just so you can see, you can do double assignment up to 2 objects and 2 people. Let's see, df small, we'll do colon 80 in this case. But just to be perfectly explicit, let's use the same index on both of those. Okay, df small dot shape, good to go. Df test. Okay, now we got our training set and our test set. Let's create the vectorizer. The vectorizer we're gonna apply to both actually. Oh, but I've already gotten rid of that df small. I don't know that I could can an incremental partial fit? Into a partial fit. Let's see what happens when I. This is gonna be tricky. So some of the words that appear in the test set won't be in the training set, but maybe that's okay. Maybe this is what we want to do anyway. Maybe this will make it a hard problem. Okay, so let's df fit on. I'm sorry, we're going to fit on the data frame small. I'm going to call that train, so it wouldn't overwrite the old one. Df small. Title. See if that works. Excellent, it worked. Okay, so we did the REPL for me because I fit it in place, and so it's returning what it did there, and it gives me a lot of more information about exactly what I did. Only like one of the important ones is like I only fit on n-grams of 1, so I only fit on individual words. So my vectors are going to end up being just words. It's the columns. So we get feature names. Let's see what those columns are going to be. So these are the words that appeared in those titles. And also another thing you can discover with this active learning is it lowercase everything. So if we looked really closely, there's some Trump in there too. You can see some of these titles. So we're going to have some good fake news and real news. Now let's see. Let's train a model from sklearn.linear linear model. Import. I forgot to import that. And create a model. I'm slow. I'm gonna rush to the end. You guys can stop me when you're ready to go. And questions. And I'll have to allow people to speak up to ask questions. I can't see the chat. Model.fit. This will be yes. Oh, I need to go a transform. Vectorizer. Transform to turn that TF small of the title into some vectors that can go into the fit. And then we need to give it the label TF small square bracket. I think it's labeled. No, is fake. Great. It trained a model at least. Now let's do a predict on all those. See, the things happen really fast when you have a small data set. It's one of the beauties of it. So those are all the predictions for the fake news. Let's look at one in particular one. Let's look DF small square bracket title. Let's see. Let's look at ILO.
Wait, didn't you just use the model to predict on another item in the model, or you just used an item in the training set to predict on another item in the training set?
I predicted on all the items. I predicted on the entire training set. So this is all of the training set and all of the predictions it made. So it predicts the first article should be an authentic article. And we're going to find out what that title was by looking at that training set. So ILO grabs the first row. I think I could probably do this a little differently, a little bit easier. OAS says Honduran vote results in doubt due to irregularities. Okay, that looks like a pretty authentic article. Let's see what the actual training set label was. I wonder if I can do two things at once here. Let's do the article, the text, and the title. And
you have to put it a list around the whole thing. Yeah.
Awesome. So it says is fake. So the actual answer got it correct. And let's look at the second one. See if that got that one correct. That should be a fake one. It's fake is 1. Great. And the prediction. Oh, we didn't do the prediction. Yeah, we did do the prediction up here. So it looks like it's doing a pretty good job. We can actually check the predictions against the truth. Let's go back to those predictions. We'll check them all, see how good it did on the training set. Or actually, let's just move the test set. Let's go straight to the test set since we're running out of time. Where's that predict? Here we go. Control R and then typing what you want to find will bring you back to what you've done before. This time I'm going to do it on DF test, I think we called it. Great. So this would be test spreads underscore. So during active learning, if you want to capture something that went to the screen, you can do that underscore trick. So let's see how many of those are correct. These are the much less likely to be correct. So we'll say test truths equals df test square bracket quote is fake. That's truths. Okay, looks like we got a lot of those badly wrong. I'm gonna just look at the values, and so we can test preds, look at right next to each other, and we'll do some math on them. So we got a lot of these wrong on the test set, whereas it looks like we were getting them right on the training set. So this is what exactly we want to do for active learning. So we'll have to take some of these that we got wrong, and we can do a predict robot. That's even better. Oh, here it is. I'm going to do predict robot. So this will tell us how close it was to get a number wrong. We could do this on the test set, on the test robot. These are probabilities that it thinks that those things are fake. Test probos. Dang. Oh, I forgot about this. So this is another good access I discovered by displaying it to the screen. I could see what was going on. Colon. I'm just going to use this is the two values: the probability of it being fake versus the probability of it being not fake, and those are one minus the other, so we don't need them both. So I'm just going to grab one of them, which is the let's see, the is fake one is going to be the second column, which is 1 in Python. So I think this will grab it. Let's try. It's not iLoc, I don't think. How do I grab the dot values? I know will work. That's how I can do it. Oh, it's already that's right. It's not a data frame. That's why I'm messing up. It's already values. Okay, so we got these are the test probas. I want to say test probas equals those. Ignore the other column. And now we got just the one column. Now I can protect that to test preds. Okay, so this is so the 0.5 just got barely over 0.5. So it wasn't too far from the right answer. And then what the test truths were. Dang. Now let's do the other one. Good. Probos. There it is. Hey. Let's do a round on that. Okay. So what do we want to do here? Well, anyway, if we're going to do machine active learning, what I'd do is I'd find these that were furthest away from the correct answer. So I'd take the test truths minus test, not preds, test probas. Don't need to do the round. So this will give me the difference. I could do np.abs to get the absolute value distance, but I don't. Let's just do the actual standard error. Actually, doesn't matter because we're just looking for the longest distance. Let's look at the absolute. Ooh. What did I call that?
You had test truths with 2 T's in the middle.
Go. There we go again. Let's make that. That looks like a. It's weird how it's creating this NumPy series. It's a series. I guess one of those things I accidentally created a series rather than a just an array. So maybe I can do dot values. Great. And we can do dot round. And we could do a sort values on that or argmax. Let's just do an argmax and just add one of those. We'll do it. I can give it multiple. If I'm going to give it 3, well, I can just get one. I can get one at a time. So the 13th one is the biggest value we've got there. So that's the example we want to add to the training set. So we just go in there to the DF test. .iloc 13 and we grab, so that gives me the row of the one that it did worse on. The US Envoy says no communication signal from somebody, and it is fake is not fake. So we can, so a true, it looks like it was predicting a lot of fake news. So we need to give it some more true articles, is basically what this is telling us. And so now how do we add that to our training set? Let's do it like this. So we do df test dot iloc. I'm going to do it like this. See if this gives me a data frame. So I want a data frame rather than great. I think that gave me a data frame. Oh, but it gave me 2 instead of just 1. 13 to 14. Oh, it gave it to me. What? No, it looks like it gave me only 1. Let's do .shape. See if that is a data frame. Yep, and it's a data frame with 1 row, so I can append that to the other one. pd.concat to put 2 data frames together, and we'll do this to the df train, I think we called it. Df small, we called it. And we need to make that a list of data frames, and that will concatenate them together. We'll say along the axis 0. This is the default, so I guess I don't need to add that. Let's just let that display to the screen first. So we now have 81 rows instead of 80 rows. So we added 1 more example, and we can put that back into the train. So it's the df. We're going to call it df train finally, so we get these things separated. And now let's put that into the training and make that run again. .fit. In this case, we're going to replace that with the train. Small is, we need to do the train again. So we'll get 81 examples and see if that works. Great. And now let's do those predictions. I normally have a function that did all 3 of them, or did the important lines. Let's see. Let's go back to where we did the error calculation. So the 2 things that we really need for that error calculation are test truths and test probas. So let's get that going. Test. So I'm going to do Control R, test truths, and go back until I find where I created it. There it is. Oh, right, because that's just grabbing that column. This is where the series came from, because this is a series, so I don't really need that. Great. Now let's do the other one, which is the Control R, was probas, I think it was. Yep. And I need to do the, I'm sorry. Test probas. Go back further. I want to find where I created that. Darn, I did a lot of stuff to it, so I'm gonna have to. Great, I think this will work. And I'm gonna do. So doing a prediction using a model. This is already going to be a data frame, and I just want to grab the columns. So I'll skip all that other stuff I had to do. So now I can do test probas. Now I can do the error calculation. What is that? You get rid of argmax. All right, so I've gotten rid of that step. Okay, we're still getting about 50% away on a lot of these guys. Not a lot of low numbers here. Let's do a dot sum. We can compare that to the previous one, and hopefully this would have gone down, because at least it should have gotten one of them better, because since we added a new, oh, but we didn't fit the vectorizer on it. So that's the fundamental problem I messed up on. We need to give it a big vocabulary in that vectorizer, so it at least knows about the words that exist in the new articles we're giving it. Probably many of those words didn't exist. Anyway, I think I've dove way too deep for most of you. So we'll back out and call it a day.